Morning, ladies and gentlemen, and welcome to panel number 12, Scaling Fiber Deployment and Connectivity Innovations. My name is Stefano. I am board member at the council. I'm also director of business development for AdTran. So today I have a very interesting line of speakers. Let me just tell you how it's going to work. So after this very short introduction, I will leave the stage to our wonderful speakers, each one of them, one by one. We will start from left to right. Each one of them will deliver to you a presentation on what is the challenge that they want to solve and how their solution solves it, actually. So after this first moment, I will take again the microphone, and I will ask to each one of our panelists one question. And then it will be the time for you to ask whatever question comes up into your mind about what has been presented. So without any further ado, let me just say that we have Corning talking about how to reach hard-to-reach rural communities. We have STL talking about the trends in the fiber, cable, and connector industry. We have Esri talking about how to deploy an integrated GIS system that actually helps the work of the operator when deploying fiber. And we have Huawei talking about the active layer, how to deploy effectively an automated active layer. So the glue of all that is how to reach rural communities, how to make fiber really a good deal for connectivity. So without any further ado, let me introduce our first panelist, Pedro Diaz with Corning. Thank you very much.
Thank you, Stefano. Good morning, everyone. Pleasure being here. My name is Pedro Diaz. I'm with Corning Optical Communications, and I'm part of the market and business development team for carrier networks. And as we try to get into a new business, we also try to find how to solve challenges. And I think we all agree that when regards to fiber deployment, there are many challenges out there. And some of those challenges that really stand out relate to rural areas. And today, I wanted to share with you some insights about what rural really means, what it is, what are the challenges and risks that we typically see in those areas, and how we at Corning are tackling those challenges with some innovative solutions. Yeah. So let's start. What is rural? I think that the honest answer, it really depends on who you ask. But when we try to define the challenges and the opportunities, it's important that we all have a common understanding and we are all at the same page of what that definition of rural is. And from experience of working closely with our customers and getting into the expert literature, we can confidently say that rural is any location with a population density of less than 150 premises per square kilometer. Now, having this definition in mind, it makes much easier to look at where rural is. Yeah. And when we look at Europe, we can clearly define three sub-levels of regions, right? We have in the green color the predominantly rural areas. We have in the yellow color the intermediate regions that are typically these suburban type of architectures. And we have obviously the high density areas, predominantly urban with the big metropolis. And what's curious about is that rural makes almost 30% of the landscape across Europe, which is quite significant. And when we look at the fiber coverage within those rural areas, we see that each country has implemented fiber at a very different pace. Yeah? We see at the darker colors the markets that are more advanced in this coverage, and on the lighter color, those that still have a lot to pass by. And overall, there's still more than 50% of deployments to be done within these rural areas. And when we think at the European targets of getting a gigabit connection by 2030 on every household, that makes a significant amount of premises to be deployed within the next few years. But let's take a closer look of how these type of rurals look like. And in Europe, we see commonly two types of rural. We have here in this picture on the left-hand side, the hamlets or the villages. There are typically these small cluster of homes within a remote area that resemble this suburban type of architectures. And then on the right-hand side, we have the distributed rural, or if you want, the ultra-rural areas that relate to these historical farming patterns where you would have houses dotted alongside the road, distant within a kilometers from each other. Yeah. And of course, each one of those rurals have its own set of risks and challenges, and there is no really one size fits all for these areas. So trying to bring some communality on what the typical risks and challenges is, what we see is long distances from the central office or from the exchange, which typically increases the time to deploy, more materials, and of course, all of this increases the cost of deployment. The non-existing or the limitations on the infrastructure that really limits you on designing and plan on how to bring fiber to these areas. And of course, on the likelihood of multiple operators wanting to reach these areas, you tend to get the risk of congestion and overbuild. Of course, the environmental and regulatory issues, where you can find sometimes very challenging terrains to dig in, and obviously dealing with the municipalities and getting all of the permits and waivers can get really, really time-consuming. And finally, the aftermath. When the network is done, you also have to operate the network and maintain, which also makes it a lot more difficult and costly to do that. So overall, this is some of the challenges that we see. And this makes imperative to bring to the market solutions that offer you the flexibility and the modularity to tackle all of those challenges as you deploy. Yeah? And what we try to do at Corning is really to offer high-quality solutions from end to end in a variety of applications, from the central office all the way to the premises, that really offer you the flexibility on the field to go overhead, underground, depending on your needs. And one of our recent innovations that we believe it really tackles and addresses more specifically these rural challenges is what we call the Evolve Openable Terminal. So this is a hybrid solution that can function as a splice-through terminal, as a splitter terminal, as well as distribution point. Yeah? So you can see that has a very small and compact design, which helps a lot on getting these waivers and permits from the municipalities may you need to deploy on facades. It's easy to open, which helps a lot with the attachment and with the maintenance. And of course, we include some advanced gel sealing technology that makes it openable and reusable over time. Yeah? As said, it offers the function to splice. It offers the function of hardened connectivity with our stick and click push lock technology that allows you to quickly connect the premises. And finally, of course, it offers you the flexibility and the scalability that you need to tackle all of those rural areas by being IP68 compliant, which makes it really suitable for aerial deployments, facade deployments, manhole deployments, you name it. Of course, also flexible feeder options. Being a stubless terminal, it also means that it's compatible with more of the existing solutions out there in the market, with no need to be introduced with new cables. On top of that, it offers you the possibility for easy network upgrades because it has supports a third cable for branching out or for network upgrades. Yeah, and yeah, this is really it. I just want to leave you with the 3 takeaways from today. Really, the focus on rural areas that make up to 30% within Europe. The challenges that are very specific to each one of the areas. We know there's no one-size-fits-all, which means there is the need for these on-field flexible solutions that really help to accelerate and also to reduce cost of those deployments. And if you are curious and want to learn more, we also recently published a white paper on best practices for rural. So you can just scan this QR code and you can go straight into this white paper. So appreciate it. Thank you very much. And feel free to pass to our Corning booth to as well play with our solutions in person. Thanks very much. Appreciate it.
Thank you, Pedro. Phil?
Thank you, Pedro.
Thank you.
Good morning, ladies and gentlemen. My name's Phil Coppin. I work with Starlight Technologies, and today I'm going to be talking about future-proofing fiber networks and how we can all prepare for the next wave of innovation. The telecom industry has been evolving at a very rapid pace. It's demanding more and more scalable networks and more resilient fiber solutions. Today I'm going to cover the trends, the major trends at a very high level that's happening in the fiber space, in the cable space, and in the connectivity space. And I'll show how all those together are enabling more cost-effective, faster rollouts, and future-ready fiber networks. So I'll begin by talking a little bit about fiber innovations. Fiber itself has been getting smaller and smaller. The glass itself hasn't reduced in diameter. That's still 125 micron. But the coating thickness has been getting smaller and smaller. The original coating diameter will be 250 micron. Now, very often, we see 200 micron fiber being deployed, and even lower than that, 190 micron and 180 micron. This reduction in fiber diameter is all about making smaller cables that can fit and maximize the duct space that's available. Now, that leads me to the next area of innovation on the fiber side of the business, and this is bend-resilient fibers. Making smaller fiber does come with its own challenges. You have to make the glass better, you have to make the coating better, you have to make the fiber more bend-resilient. And in ways we can do this is by converting from the early generation D fibers to the more bend-resilient G657A1 fibers and the trench-assisted designs with a very low bend sensitivity of A2. This enhances the durability of the fiber so that it can be cabled and packaged into a very small form-fit package with very high fiber density. So the first 2 innovations I've mentioned there are really all about standard single mode fiber. The next 2 innovations are big industry trends, big innovations that are happening in the industry right now. The third one I want to talk about is multi-core fiber. And this is where you can dramatically increase the capacity of your single mode fiber. Suddenly, your fiber changes from a single fiber core to either a 4 cores in the same 125 micron glass diameter. This immediately quadruples your fiber carrying capacity without increasing the cable size. And then the last fiber trend that's very much a hot topic at the moment, the technology has been around for quite some time, but it's now coming into the field deployment stage now, which is called hollow core fiber. All the fibers I've talked about so far have solid glass cores. The hollow core fiber actually transmits light through air, through a hollow core. And this has two big benefits. The first one is light travels faster in air than it does in glass. So you actually reduce the latency. The second big benefit is that potentially this hollow core fiber light has the potential to have less attenuation. So you can actually reduce the attenuation of your fiber below the theoretical minimum of a glass fiber. So this is revolutionizing latency and fiber loss with hollow core technologies. Why does this matter? It's all about future-proofing your network for ultra-high bandwidth compute required for AI, 5G, and ultra-low latency. That's a little bit about what's happening in fiber. Fiber's getting smaller. Not surprisingly, cable's getting smaller as well. So the two big trends I'm going to talk about is high-density microcables. It's not a recent innovation. This is more like a continuous improvement. For the last 10, 12 years, cable diameters have been getting smaller and smaller and smaller. It never ceases to amaze me how we can each year launch a new, even smaller diameter cable. Back 10 years ago, a conventional 72 fiber cable could be as big as 11 millimeters, and it would only fit in a 25 by 20 duct. Nowadays, it's very common to see a 288 fiber cable, micro cable, in a very small 7 millimeter diameter, which blows beautifully in a 12 by 10 smaller subduct. So what this has enabled us is to quadruple the fiber density in smaller ducts, so it's optimizing fiber deployments in very congested duct spaces. The whole of Europe network is very congested duct spaces, so this is a real necessary requirement for building fiber networks in Europe. That's the first cable innovation I wanted to talk about. The second area, the big trend that's happening in cable is ribbon, and specifically for Europe, rollable ribbon, because Europe needs small cables, and it's only the rollable technology of ribbon that truly gives you small cables. Rollable ribbon looks like a typical ribbon, typically 12 fibers joined, but instead of fully encapsulating the whole 12 fibers, they're spot welded, they're intermittently bonded. This makes the ribbon structure very flexible, but very rollable. It allows you to pack the ribbon very tightly into a very small form factor cable. So these intermittently bonded ribbons have one big benefit. They splice much faster than a single fiber cable. The time it takes to splice a single fiber cable, you can do 12 fibers at the same time. So typically they install 4 times faster than a regular single fiber cable. So it really speeds up the deployment. The other big advantage for network operators is it allows you to repair your networks very quickly. In the event of a very inadvertent dig-up, if you've got a very high fiber count cable, it's difficult to repair it and splice it within a few hours without facing penalties. With a ribbon cable, you can confidently install high fiber count cables, 288, 432, 864, and still restore that cable in the event of an accidental dig-up within a couple of hours. So these are two cable innovations that are happening, two trends in the cabling world that are building higher fiber density networks. And the ribbon technology is also used a lot in data center interconnect, where you see some ultra-high fiber counts, sometimes nearly as high as 2,000, 3,000, 6,000 fibers in a single cable. The only way you can build those cables and install those cables is using ribbon technology. And then the final connectivity innovation, we heard earlier from our colleague at Corning, the rural deployment. We've done a lot of home passes in Europe. We need to do a lot more home connects now. And one of the fastest, most efficient ways of doing home connects is using pre-terminated, connectorized drop cables. And there's no one single solution that fits all deployments. Different networks require different drop type constructions. And I've just got an example here of 2 or 3 different technologies of connectorized solutions. The first one on the left you see is our regular hardened connector. It's fully ruggedized, it's fully IP68, and it allows a very quick and rapid plug-and-play install. The second connector solution in the middle is what we call a connector ruggedized shell. It's almost semi-hardened in that it uses a standard indoor connector, maybe an LCPC indoor connector, and then over the top of that connector, it builds a ruggedized shell. It quickly assembles a ruggedized shell that plugs into your customer terminal very easily and quickly. So we call that a CRS solution. And then both these hardened connector solutions are ideal, universal for both underground and overhead installation. But one very popular installation methodology in Europe is to blow cables. You can't normally blow a connectorized cable, but you can. Now we can. And the way you can blow a connectorized cable is by first disassembling the connector and taking a very small drop cable, and on the end of the cable, just fixing the ferrule, the ceramic ferrule, the center part of the connector. You splice that in the factory onto the cable, then that cable can be blown in to the customer premise or to the distribution terminal. Then when it reaches its destination, you then assemble, click and fit the green connector body around it, and then you plug the cable directly in. So here's a few different connector solutions that are extremely important for our connector drop network now. It reduces installation time for millions of homes, it increases network resilience, and it lowers build costs. So hopefully I've talked a little bit today about how advanced fiber, cable, connectivity, all the passive infrastructure can help network operators build efficiently and effectively. We've used all these technologies with customers throughout Europe and the world, and we've seen real-world faster rollouts, 30% quicker builds, lower costs, 25%, up to 25% lower build costs, and increased durability, long-life, future-proof networks that work in today's high-speed network, but also work in tomorrow's even higher speed networks. We're available, Starlight is available in the exhibition hall. I appreciate this is a very quick, high-level overview of some of the industry trends. If anybody has any interest or needs to learn a little bit more about that, please come by the booth and we can give you more information on all these technologies and innovations. Thank you very much.
Well, hello, everybody. My name is Randall Renee, and I'm the industry director for Esri for telecommunications. In my role, I get to work with a lot of telecommunications providers, service providers, infrastructure owners, et cetera, and challenge them on thinking differently about how we build, manage, operate, and maintain our networks. Since the dawn of humankind, we've always used maps. Maps are very important to us as they give us some sort of visual context of a real-world problem. And in today's business place and in our industry, we know that business happens at the speed of decision-making. Well, behind those decisions is a need for understanding before people take action. And where once we had limited input to make a decision or needs of information to make a decision, we now have much more that our teams have to contend with in order to understand before they take action. So the need for context and visualization of data and information is quite profound these days. All of us have our smartphones in our pockets that are tailored to our lives, so why aren't our business systems that we work with, such as operations or business support systems, also tailored to our workers? Throughout the world, we have really 4 big areas that we focus on: people, productivity, profitability, and the planet. Every goal we have and everything our teams do is boiling up into these large, rather important areas. Today, I'd rather talk about 3 of these areas that much of the KPI that our teams have behind the scenes, those individual contributors, are rolling up to things such as network planning and operations, as we're speaking about here, customer insights, whether it's partners or internal employees, or even those entities we work with, such as government agencies, and sustainable efforts in our workplace. Our legacy systems, however, do not keep pace with the work that we have to do in order to meet customer demands. Legacy operations and business support systems, and even modern operations business and support systems, often have their own user interface. They have a GUI or a report or some sort of map that goes along with that information. This requires our teams to have multiple monitors on their desk or to have further interactions with other team members as they need information to make that educated decision or to complete that task. In this example, we'll focus on network management, which is predominantly my background. I was a planning and design manager for many years, organization named Comcast in the US. Typical network management systems or work order management systems are usable only for certain teams, unless they're integrated. What we do at Esri is we help teams and companies and individuals overcome some of these siloed, some of the problems and inefficiencies that these really great business systems like a biller or a network design platform, they introduce by simply having to ask where, when, why, how, and what of a job, or could you make me a map? That was my team's least favorite request we had. All of these small requests, whether emails or somebody stopping by your office, they add up into elongated time frames. So what we focus on is breaking down those silos. And what it looks like to break down silos with leveraging ArcGIS is not replacing those operations and business support systems. Those are tried and true and often quite expensive and cumbersome in a business. I challenge you to think differently about how you interact with those, as the technologies today allow us to support the entire organization with GIS by taking and organizing, using the power of location as the tie that binds, all of these different seemingly disparate data sets to location. We leverage geospatial services to tie those into layers within GIS to create these maps and apps and layers that can then be leveraged in purpose-built business systems. So in this case, you see what I call establishing a single and authoritative source of truth. We all know that our teams print out maps, they print out data, they have their own records because they want to be the best at what they do. And no one wants to do a bad job, and no one wants to dislike the job that they're doing. This ensures that as you create layers, whether it's Esri curated data, your own operations and business support systems, or third-party data such as satellite imagery, LiDAR, real estate, competitive intelligence, all of these things allow you to create and deliver purpose-built business resources. Really give your team members that single pane of glass that is analyzed or visualized and trusted, secure, and delivered to them in real time. So whether it's from executives such as government affairs looking at project management, or all the way over to a line of business manager that's taking a look at a knock level for impending storms and whether they should move traffic to another circuit. All of these typically come from a variety of different operations and business support systems. So Enterprise GIS, to me in telecom, having been a user for many years and now in my role, I focus on 4 big areas. The wireline, fiber to the home, much like this conference here, the wireless assets, infrastructure, and then those services groups that are building, designing, engineering, and digging ditches to get us the cable to the locations we're serving. These different organizations, as they're working throughout the networks, whether from the central office, I spent 12 years myself in central offices, all the way out to the customers, there's a lot of work that happens in our networks. So how do we keep pulse of that? How do we keep our teams informed and allow them to make the best possible decisions as fast as possible? Well, on the left, you see we integrate ArcGIS into those operations and business support systems to then create those tools for those teams and to deliver those purpose-built resources. Whether it's executives, sales market development, understand saleability, or rural expansion needs. I love the maps you showed earlier about that. That's something that we've all worked on to some degree. We want to make sure that as we're looking at planning our network and operating on our network, where our teams once used, and still in many cases use, legacy systems, very, very important systems, they have a variety of maps and apps and dashboards and various things that they have to look at. But what they're really craving and what we find most successful, whether it's from government agencies, militaries, other utilities, all the way down to small companies with only a few people, the need is the same. Give me a purpose-built business solution that empowers me to make the best possible decision as fast as possible so that I can take care of my customer, I can make my earnings, all of these metrics that are behind what we do. Customer insights as well, as opposed to if you were to ask what's the customer satisfaction or what's the needs for timelines associated with a rural build-out, are my metrics going to have to change? These are things that people are typically having to take a team to a conference room with a host of data to create a plan to then present to leadership as to what tactics or actions are going to be made. Instead, what we do with Esri is we help teams create these automated workflows that reference the information, prepare reports in a visually impactful, easy to share method, both with the government agencies, internal employees, or whomever else needs to look at this. So another example as we focus on the third one, sustainability. And we want to be resilient in what we create. We want to be proactive in taking care of our environment and to be good stewards of our environment. If somebody asked my design team back when I was at Comcast, what's my carbon footprint impact or my fuel expenses going to be as I expand my network out into the rural periphery of my region? That would be a very complex task. What we help is with GIS to be able to, as you see in the bottom here, which unfortunately is not playing, is to be able to create and leverage geospatial analysis tools to gauge drive time distances, to understand carbon footprint impact, to be able to route our technicians efficiently so we can expand while meeting our goals, and then ultimately, we're good stewards of our environment. There's a wide variety of different types of solutions I could place up here, but I chose these three areas for the purpose of this conference, as they really seem to speak about how as we look at how we can move forward together in being better decision makers, better, the actions we take are more informed and the outcomes larger. Think about leveraging the power of location to gain intelligence and to use ArcGIS as a way to pull those operations and business support systems together. It might surprise you to know that almost 90% of FTTH members are already leveraging Esri in some way. This is something that I always like to come to the conference and speak about because many people in their organizations don't know this. So I challenge you to stop by our booth and understand if you are already a customer, because we would love to help you get the most out of your system as you're expanding networks and taking care of your customers. How to establish a single source of truth and get away from those network maps that are in somebody's truck, or somebody like I had people on my team who had almost the entire splice documentation system memorized in their head. That we have people like this. Let's help them get that in a system so we can deliver insight and context to our teams and ultimately eliminate those siloed resources and deliver purpose-built resources to our teams. We are here at the conference as well. Feel free to stop by and take a look, and I appreciate all of your time. Thank you.
Good morning, ladies and gentlemen. This is Zhichen Ye, the Chief Architect of Optical Access Network from Huawei Company. I'm very glad to attend this workshop and to share with you this topic, Fixed Access Network Intelligent Engine, the key enabler for end-to-end quality of experience. So we have talking a long time for triple play, the HSI, voice IP, and IPTV, Nowadays, the emerging applications continually remind us we are not sufficient. Versatile provision is needed to support AI, metaverse, robotics, and so on. New business model is needed, and camera have been acknowledged by the industry with increasing members in these years to provide the dynamic quality on-demand APIs. The autonomous networking have been proposed via TM forum with specifying the 5 levels of automotive together with 4 closed loops in the architecture. The latest blueprints shared the effort of industry towards L4 with intelligent, and a few high-value use cases are specified for the access and home network, including service assurance, complaint handling, and troubleshooting. These are also efforts other standards organizations, ETSI, in emphasizing the experience. ITOT defines the enhancement on the equipment to support intelligent operations. And in broadband forum as automated intelligent management in home and access network. Towards these trends, we are proposing the innovative architecture named FIE, Fixed Access Network Intelligent Engine, the FAN Intelligent Engine to help on providing new service, new business, and technologies. FIE provides the digitalization with open interface, which enables the full automation in the life cycle. Network as a service could be supported in the deterministic way to guarantee the user experience. It is acknowledged by the ETSI F5G advanced to have a 6-dimension framework, and FIE provides the supporting by hierarchical intelligence on the network level and devices. Awareness, computation, connectivity, storage, and control are the key in this loop. Service-led broadband has been confirmed as the strategy from Broadband Forum, with the quality of experience becoming the key long-term objective. But we need to answer the question, how to decompose the task and achieve it. We confirmed with multiple service providers and analysis and found that the differentiation should be important an approach, as the different flow is having the different SLA and could be categorized into different layers, accomplished by different technology. So the key enabler of quality of experience management is to have application level flow, where we call APP flow here. This security and sustainability are the question we must answer, how to guarantee the security among the APP flows. The management on one flow should not impact the others. This could be achieved by slicing and FAN sharing technologies in BBF TR370, by flexible sharing the infrastructure and isolation with others. We can finally allow one user, one management, and one policy, one price for a closed loop business. Such management including the network and service capabilities, number of API to be used, and securities. After the security, we look at the sustainability. A two-step approach is to use to give the service provider clear management and policies. Firstly, we need to make it visible how much power is used in the current network. And then we can talk about the objective for power saving. Secondly, we need to figure out what possible solution we have in our pocket and then specify policies for power saving. The intelligence could help recognizing the special event in the internet and therefore enable the switching between one policy and another. So the key would be prediction. What is going to happen in the network and how to recognize it rapidly, accurately, and even in advance. This depends on training big data and develop right model and algorithm. So preliminary trial should show that 62% of poor QoE could be avoided by the adjustment based on intelligent prediction and improve the experience accordingly. Meanwhile, 60% of the troubleshooting time should be saved. When we talk about the QoE, it's not single domain or single technology, which should be E2E, quality of experience. Coordination needs to be emphasized when there are multiple segments connecting with each other, the upstream, home network, and Wi-Fi. Enabling real-time negotiation improves 30% of bandwidth, solves 95% of coverage problem, and generally increase the ARPU by 30%. There have been great effort in various standard organizations for the architecture environment. ITUT G.Supply 74 specifies the slicing functions in the PON network and followed up with latency management. ICT enhancement of the ORT is initiated in the G.EORT and the comprehensive capabilities of awareness, computation, connection, storage, and control. On the other end, the improvised network focus on the digitalization, ICT enhancement. The coordination between the two questions are also under investigation. Broadband Forum kick off the Cloud CO 2.0 with multiple features, extending to multiple domains and requesting better orchestration. Enhanced capability are considered to achieve the AI empowerment from the AIM. Two ISGs in ETSI, the F5G and the ZSM, are also investigation on the intelligence. F5G architecture mentioned that the management is complemented by the control of the analysis, so that the slicing across multiple technologies network could be management, which is just the APP flow in the previous page. Collaborations for computing on the ORT, ONU, and FTTR are under study. ZSM is studying the digital twins. We are moving to the summary. Our target is Cloud CO 2.0, the quality of experience improvement as the objective, and using FIE as a target architecture for the broadband network. Intelligence will be centralized on the cloud NMS and distributed on the devices. Differential would be the key for civilization and monetization, and intelligence would be the key methodology. That's all. Thank you.
Now is question time. So, like I said, I will ask each one of the panelists one question, but then I will open the mic for any curiosity from the people. Okay, so let's start with you, Pedro. So we saw that the current solution looks really interesting to address hard-to-reach communities, but can you comment on the savings with respect to a more traditional solution of your solution, and if there are already some customers that have adopted it?
Thank you. Thank you for the question, Stefano. Very, very pertinent. And yeah, when it comes to typical deployments, you saw from the presentation that there's really no such thing as one deployment that fits everybody, right? So when we look at rural areas, we have to go almost on a case-by-case scenario, and it's a little bit of a black canvas. But what I can share with you is an example of an outnet in the UK, and the way they were deploying is they were bringing the fiber to those remote areas through bringing the feeder on a splice joint. They were splicing, and then they were having to integrate another terminal to bring the fiber to the premises, right? And with the Evolve openable terminal, you saw that it sort of aggregates both functions in one footprint, and this allows them to eliminate one of those closures. If we think, typically those closures will range around €100 per per terminal. And if you add up the fact that it's easy to install, faster to deploy, easy to connect, allows you for this less labor skill. And if you sum up everything, we estimate that the savings per home pass can range at about 10 to 20 euro per home pass. And if you extrapolate this to a few million premises, savings can be highly significant. So yeah, we are learning as we grow, and customer by customer. But yes, this is some high-level estimates that we have with the EOT.
Appreciate. Thank you very much. Nice data points, by the way.
Thank you.
Let's come to Phil. I loved your presentation and all the. I honestly didn't know that were so many innovations on the road for fiber cables and connectors. So, can you just comment on the status of realization of these innovations? Are there already all of them available, or which one is coming first, and which one is still has to be engineered a little bit more? And sorry, if there are already some pioneer operators deploying them.
Okay, so I think I'll concentrate on the fiber side of the business, the fiber innovations. The first two fiber innovations I talked about was smaller diameter fibers and the bend resilient fibers. They've been continuously improving over a number of years now, and so they're very well industrialized. All the big manufacturers have these smaller diameter fibers and more bend resilient fibers. The latter two fiber developments are more in the early stages. I would say the multi-core fiber, there's been some really interesting work done by many suppliers. We were quite proud of the fact that we've developed and deployed a multi-core cable. So we made the glass, made the fiber, put it into a cable, and installed it in a government network back in India. And it was really encouraging to see that we got great fiber performance. All four cores operated with the same low loss that you would expect in a single fiber core, and at full high speed as well. We did 800 gig transmission with minimal zero influence of crosstalk, so they were really giving a 4x bandwidth capacity installation. So it's nice to see that come out of the lab and go into a real world installation. And the last fiber innovation, the hollow core fiber, this is really the new kid on the block. There's lots of interest, especially with the acquisition of Microsoft, of Luminosity. They're one of the early pioneers. We've seen some really interesting lab work, some really interesting trials. Photonic bandgap fibers tend to be slightly higher on the attenuations, so maybe less practical. The trials we've seen on that technology are typically smaller range, higher attenuation. The anti-resonant fibers, though, they look really interesting. We've seen longer installation deployments, 30 to 40 kilometers, and with very low loss, lower loss than the standard signal fiber, 0.17 dB, and even as low as 0.11 in a lab. But we've seen some real-world deployments of the hollow core fibers as well now. It's still early days. There's a lot of industrialization, and it's probably not really an FTTH type market. It's more, I think, a high compute, a data center type environment for that technology.
Thank you very much. Now to you, Randall. Yeah. So, very interesting your presentation. By the way, you can teach all of us how to do a PowerPoint presentation. I think it was really amazing.
My second master's degree is in PowerPoint, yeah.
So, your software also, I liked your, let's say, the holistic approach of ArcGIS being the single source of truth for the whole spatial ecosystem. My point is, as you already signaled, there are already some existing systems which are maybe older, and they contain part of the data that the operator would like to ingest into your system. So my question is, in this case, which is probably very it happens very often. How would you work? How do you integrate all the data into your solution?
That's a great question, and thanks for that. When we think about what Esri does, we spend, first and foremost, about 30% of our revenue on research and development. And it's to ensure that we're able to bring the latest technology, but also provide the highest security and integrate with the widest variety of data sets and information. So a variety of APIs or SDKs or numerous other ways and formats that we're able to integrate existing business systems. I can give an example, for instance, as you're working on planning and design. You might want geological reports to show the kind of information, the kind of soil composition. Is it rock? Is it sand? The buildings, the natural and built environment of that region. All of these factors, such as sensitive ecosystems or maybe burial grounds, et cetera, for different tribal nations, et cetera. You want all this as decision making, and those come maybe from different assets. But then you bring in your existing customer data, parcel data, capacity metrics, your network design, all in different systems. Most data sets out there, there's a way to export that data. And because there's a way to export that data, we can tie that to GIS. We find very few systems that we can't integrate with. Some systems can be problematic. There's network design platforms, for instance, that by nature of the way that they detail that information, it's hard to integrate. But we have ways. It's just not as useful. With some of these integrations, such as a biller or a job management system, we can actually have a two-way communication. So being able to create a web app that allows somebody to see their map, see capacity metrics, see trouble tickets, tech locations and GPS systems, all within a single pane of glass so that other monitor becomes their resources as opposed to one more GUI to work with. We find that we are able to do this across, it's about 700,000 organizations worldwide, and those organizations range from the United Nations to world governments, utilities, down to small mom and pop shops that are just trying to deliver food to people. Our product scales and is aligned to as many resources as possible so that we can integrate that data and really simplify what people have to do these days.
Thank you very much.
Yeah, thank you.
Yeah, so the Huawei Fan Intelligent Engine really looks like really a great solution to deliver automation, efficiency to the active layer of the network. So my question is it a solution that works only where the end-to-end components are Huawei, or it accepts a multi-vendor environment? What's the status of the standards behind it? Does the standard allow for this solution to be multi-vendor?
Okay, so firstly, I would like to clarify that FIE is not a Huawei solution, but has been credited by the industry in the ITUT and ETSI standards. The key of FIE is optimization, intelligence, and civilization. To achieve this benefit, the standard works are focused on reading a consent of on the objective and a general framework and architecture. The interoperation will be considered in future steps as well. So we would confirm that FIE is an open architecture with coordination with multiple parties. It is not a single vendor solution, and we look forward to seeing the joint effort from industry and to construct together. Yeah, thank you.
Thank you very much. And let's stretch my legs. And now, and now it's up to you guys. Any questions from the audience? Any curiosity? She's coming to anyone that has any curiosity? Yep, we have one there.
Yeah, this is Yaman Sakurai of Fujikura Europe. So I'm a little bit excited about the comment from Philip from STL. Thank you very much for it. And in terms of the FTTH, you are handling. You showed us the showcase of the ribbon cables, which Fujikura is also promoting to the European market. And what do you think of probably 1 year or 2 years? I do not know how long the FTTH boom actually continues or not. And then how the ribbon is accepted by European market. But you probably have some visions or something to introduce the ribbon technology to a European market.
Okay.
This is a question
Yeah.
for whom in particular? For you.
Yeah.
Sorry.
Okay, thank you for the question. The ribbon technology is very mature now. When it was first installed and first used and deployed, the telco that deployed it in the UK was thinking really it was only relevant to the 432 fiber cable, the very high fiber count cables. However, on actual deployment, it saw such big time savings that they realized that they could even deploy the same technology in lower fiber counts. So then they started to deploy it into 288 fiber cables and then 144. And then some other network operators even deployed it even lower down to 96. So the ribbon technology is generally the backbone of the trunk of the fiber access network. But it is going to lower and lower fiber counts as well. In terms of acceptance of the market, the ribbon technology, it's really funny because the US market loves ribbon, but they love high fiber counts, so it's the only way they can really install big fat cables. Europe was resistant because generally the ribbon cables were big and fat. However, these rollable ribbons are small and compact, so they now start to fit into European ducts. However, there's still a big divide. There's only really the UK that's wholeheartedly adopted the ribbon technology. And it's not just the big national telco, the BTs of the UK, but all the other big telcos in the UK are widely deploying the ribbon technology because the installer infrastructure is now converted. They have all the splice machines, the ribbon splice machines. Europe, I've seen a slower pace of adoption. It's not really been deployed anywhere else in mainland Europe at the moment, but I can only think as fiber counts progressively get higher, it becomes a more and more obvious solution to use a ribbon technology. And the other big proponent of ribbon technology is the data center guys. And that's the only way they can connect is the ultra-high fiber count cables. So even in Europe, the data center guys are connecting with ribbon cables. I hope that answers your question.
I'd like to add to that if I could.
Yeah, go.
You know, when I was a planning and design manager in the US, we started gravitating to using ribbon cable because of the weight. We could get a higher density fiber count. A 432 fiber count was lighter than a 288 count, standard, fiber because when you're dealing with aerial networks, when they've got to go along utility pole lines, which a large percentage of the US market is, the weight matters as you're calculating pole loading. So you try to get as much on the pole as possible. So I know Europe is a lot of underground, but weight is a key factor.
And that's a good thing because the underground cables, the micro cables, tend to be lower tensile because they're designed to be blown under minimum load. But the ribbon cables are blown in as well. They're installed by blowing, but they've got a very high tensile performance as well, so they can be equally pulled or used aerially as well. So they're quite universal in their deployment.
Okay. Any other questions? Any curiosity for our panelists?
It's your time to stump us. I'm ready.
Okay. Thank you very much then. And can I ask you for a last round of applause for our panelists, please? Thank you very much, guys. Good job.